Hey everyone, let's go ahead and get started with today's notes on property of logarithms. So this link here is going to be talking about our next step. We're already done with the test. If you did not take the test, you will be taking it on Wednesday, is the date that I currently have planned in class. And then if you want to do test corrections, the only day I'll be offering that is Thursday after school. So with this here, I want you guys to take a minute and look on your calculator. Pause the video if you need to, and I want you to find two buttons. The first one is going to have the word log, and the other button is going to have natural log. It'll just say ln. So once you find those two, go ahead and come back to the video, and we will talk about the rest of this lesson. All right, so we are going to be talking about natural logs, and natural logs have a base of e. So these ones here, they're not going to write base 10 because it's not 10, it's e. And remember that e itself is a number, and we calculate that number as 2.7182. Okay, so whenever you see something with a base e, they're going to replace it with a natural log, and they're going to replace it, you'll see the letters ln that represent that. So given our irrational number, and given that this base is used a lot, let's look at what the how we write it. So typically we would have log e of x, and since they wrote log e so often, or log with the base of e, they decided to give it its own inscription, and they write that as ln. ln again is referred to as a natural log. So in the beginning, for these first 5 problems, all we're going to practice doing is taking an exponential, a log with the base e, and we're going to write it as a natural log. So the first one, I'm going to show you an expanded form, and then after that, we're just going to go ahead and write them using natural log. Okay. So this very first one, e to the 3rd power equals x. If I wanted to write that in log form, I've got log base e. Remember that these two here appear to swap places. So log base e of x is equal to 3. So log e to what power would give me 3 is how that's read. Okay, or log e to the x power will equal 3. We're writing it in natural log form. Again, whenever I see log base e, I'm going to rewrite that as a natural log. So ln of x equals 3. Okay, all right, let's go over to number 2. On this one here, e to the power of 0.6931 is just about 2, but just about, remember that means that they rounded. So we are going to go ahead and rewrite this in natural log form. So since the base is e, I know that this is going to be a natural log. So ln of 2 will be estimated to be 0.6931. Okay. Okay. All right, now for number 3, again, it has the base e, so I know I'm going to be using natural logs. The 7 and x plus 1, the argument and the exponent are going to be swapping places. So I have a natural log of x plus 1 equals 7. Now, just came to me, some of you are wondering what happened to that e. So I want you to look back and notice that we had the e. Looking back at number 1, we did have a base e, but whenever we have log e, that gets written as a natural log. Okay, so it's not that it's gone, it's just that it's used so often that they decided to turn it into its own variables of ln. Okay, number 4. On this one here, base e, so I know that I'm going to have a natural log of 36 is equal to x. So e to what power, or e to the 36th power, gives me what value? All right, on this one here, base e, x minus 9 and 74 are going to swap locations. So natural log of 74 is going to be equal to x minus 9. Okay. All right, on the next three here, we are going to take something that's already written in natural log form, and we are going to convert it into exponential form. So since it's a natural log, I know that that means it's going to have base e. These two here will swap locations. So we will have e to the x equals 5. Over here, I've got a natural log again. So x minus 7 and 18 are going to swap locations. The base is e to the 18th power equals x minus 7. And then on number 8, again, we have a natural log, gives us a base e. So 87 and x plus 4 will swap places. So e to the x plus 4 power. If you'd like, you can go ahead and place those in parentheses, equals 87. Okay. All right, so now we're going to go on to evaluating logs with change of base. I do want you to have that pink paper in front of you for the first one because I want to take a look at a couple of things, okay? And again, your calculator. You definitely need a calculator. If you don't have one, please pause the video and go pick one up. All right, so evaluating logs with change of base formula. This is when I can't find that the base can equal the argument in that I can think of looking at that pink sheet. So here what we're going to do is we are going to take the log of the argument divided by log of the base. Okay, so log of the argument divided by log of the base. So log of the argument divided by log of the base. Now, remember when you're entering these in your calculator, we need to enter them backwards. So for example, if I had log of 10, that's probably not the best number to use. Let's say I had log of 7 divided by log of 3. Then in your calculator, you would type in 7 log divided by 3 log. Okay. All right. So let's go ahead and go on to number 9, evaluating. This one here, if you were to look at your pink paper, see if you can find a value, which number 2 times what, or 2 times what power, nope, that came out wrong. 2 to what power would give me 260. So when you're looking at your pink paper, when you're trying to find that, there won't be one because it's not a perfect value based off of what our chart gives us. So to evaluate this using our calculator, I'm first going to write it in change of base form. So I'm going to have log of the argument divided by log of the base. Okay, so log of 260 divided by log of 2. Now in your calculator, you're going to type in 260 log divided by 2 log. And these ones are going to give us decimals, so I'm going to put our estimated equal sign so we know that this was not exact and that we were rounding. I'm going to go 4 decimal places. So this one here will give us 8.0224 once we've got that rounded. Okay. All right, on number 10, 1/6 to what power will give me 35? And there isn't one. If that was 36, that would work. Okay. Now, I also know since one's a fraction and one's a whole number, this answer is going to be negative. So using change of base, I'm going to have log of 35 divided by log of 1/6. Okay, remember there is a fraction button on the calculator. It's in the bottom left corner. It says ABC on it. So when you enter this, go ahead and enter 35 log divided by 1 fraction 6 log. And this one here is also 4 digits. It is an estimated answer. It is negative. So negative 1.9843. Okay. All right, on number 11, 16 to 1, what power could give me 1/3? Or even if you're thinking about it in the reverse order, 3 to what power could give me 16? Okay, but that there you wouldn't be able to find one looking on your pink paper. So we're going to go ahead and use change of base. So we've got log of the argument, so log of 1/3, divided by log of 16. Okay, enter that into your calculator so that you have 1 fraction 3 log divided by 16 log. This one as well is going to be a negative because we have a whole number and a fraction. And this one will be negative 0.3962. Okay. All right, number 12 on this problem here. I'm going to take log of the argument divided by log of the base. Go ahead and plug that into your calculator. Now this one is going to be a positive number. Now you may think they're both not fractions, but this decimal here can actually be written as a fraction if it was 225 over 1,000 because it is in the thousands place. Okay. So this one here will be a positive number, and your solution will be approximately, okay, let me get my pencil to work, approximately 1.3578. Okay, remember I'm rounding on that 4th digit. Number 12, so for this one here, we are going to do log of 20, and hopefully you're catching on to what we're doing here every time, by log of the base. So log of 20 divided by log of 7. And this one will give me 1.5395. Now remember, you got to round by looking at that 5th digit. If it's 5 or higher, we round up. If it's less than 5, it stays the same. Okay. All right, number 14. I have got log of the argument, which is 9, divided by log of the base. Now remember, when they don't give us a base, that is when it's understood to be 10. If they had said natural log, ln of 9, then that base would be e. But when they don't give us a base down here, it is 10. So log of 9 divided by log of 10. And this will give us 0.954. And I don't have that last digit. If I'm correct, it's 1. But I don't have that one, so I'm going to leave that one there for you. All right, number 15, evaluating the log to round to the nearest 10,000ths place. Remember, that's 4 digits past the decimal. Use the natural log button on your calculator. Now, with natural log, whenever you use natural log, the calculator already understands that the base is e. So all you have to do is type in natural log of radical 3. But on this calculator, you have to type in radical 3 and then the natural log button. Now the radical button, I believe you have to hit second, and I believe it's towards the top right somewhere, but find that one, type in radical 3, ln, and then hit equal. This one here will come out to about 0.5493. Okay, number 16. Again, it's a natural log, and This one, we're just going to type in natural log. We understand that on this one, the base is e. So natural log ln, or 20 ln, will give us 2.9957. And for number 17, type in the fraction and then type in the button that says ln. So 2 fraction 3 ln, and this one here, it is going to give us a negative. All right, and that is it. So for you, your homework tonight, you have two options. One, if there's a printout, you can work off the printout. If there's not a printout, then I want you to go to Canvas, find the homework page here, and then complete these problems. Once you have completed them, please upload this to Canvas. You should have time in class to finish this, but if not, it is due, submitted by Monday at 8:30 at the latest, okay? All right, you all have a great night, and I will see you next week.